Hello everybody, welcome to the fourth video of Unit 2, Algebraic Flow Proofs. This is on page 141 and 151, which we're really cruising along in the textbook, which is awesome. And our objective today is to analyze and construct arguments in two different proof formats. One is going to be a flow proof, and the second is a column proofs. And I have this one starred only because we're going to introduce what it looks like. We're not really going to deal with it entirely. So you're not going to see an example in that form shown. You're going to have to fill it in just to be able to compare what a flow and a column proof look like. Okay, so let's take a look at some examples of non-related geometry, not even math related at all, to kind of get in the idea of what kind of deductive reasoning we need to be able to show that these are true conditional statements. So let's go ahead and look at those first two examples. So again, for each conditional statement below, state whether the statement is true or not, or true or false. If it is true, use evidence as to why it is. If it is false, provide a counterexample. So you have two examples. If next month is August, then this month is July. And our second example is if you have a civil case in the United States, then you have the right to a jury. Hopefully after taking a look at them and reading them maybe again on your own, you can recognize that both of these are indeed true. So there's no need, true, not false. There's no need for, let me go ahead and rewrite that. There's no need for a counterexample. They're both going to be true. So if they're both true, let's talk about why. We can't simply state that I know July comes before August. Okay, again, that might come from experience. That might come from a pattern of every year that happens. That would be using inductive reasoning to show this is true. We want to only use deductive. So I need a fact. I need an exact idea or a definition that makes this true. And that's because of this thing called the Gregorian calendar. The Gregorian calendar, and as I'm writing here, I realize I've been called out many a times for my handwriting, so I'll make sure I do a better job of making this legible so people don't stop me in the hall and tell me my handwriting's terrible, which I understand it's not great, but again, making sure I'll do my best here. So the Gregorian calendar, though, is the reason July comes before August. That is a fact. That is the type of calendar that we use in the United States and most of the world uses. So again, that's our piece of evidence to show that it is true. So the second piece, though, if you have a civil case in the United States, then you have the right to a jury. In that scenario, if you're in civics class, you may already have this answer before I write it down, but this is because of the Bill of Rights. The Bill of Rights specifically, and I'm going to abbreviate, it's Amendment 7. Specifically, the 7th Amendment of the Bill of Rights is the reason that if you have a civil case brought to a court, you're going to have the right to a free and unbiased jury. So we can use specific, in this case, laws, or in the first scenario, a specific type of calendar to allow us to draw these conclusions. So that is our fact or our evidence that allows us to deductively conclude that both of those statements are true. So we're going to look at this more formally if you go ahead and look down the bottom of your page in how we actually construct these proofs we're talking about. So we're going to highlight a few things here in yellow so you understand what you need to write down. So the first thing is that you're always going to be given a piece of information. And I'm going to highlight one word that's changed on yours, not on mine. This should say word, not work. So write the given statement in a box with the word given underneath. So guaranteed, no matter which proof you do, if you restate what you've already been given, you're guaranteed some credit for that attempt of that proof. The second piece is to then link about what pieces of evidence, like the Bill of Rights or like the Gregorian calendar, can we use to show that this is indeed a provable or a true statement. And there's two things to write there. First is the chain of evidence, and then it says create a deductive argument by forming a chain of statements linking the given that we had at the beginning to our solution, which is our statement at the end. So this whole idea is to connect number 1 to number 3. That's why we have the chain of evidence. And each time you give a piece of evidence or reason or property, you need to show it, which is the same as in this case, justifying it. So justifying it, presenting it as your final evidence is to actually show it by writing it down. So kind of that idea of all those years of showing work, it's paying off in a proof. You have to show that work, or otherwise your argument isn't valid. You have to provide that evidence. And finally, that prove statement, which is state what it is that you have proved, which is the last step. And the cool part is that's going to be the conclusion statement at the beginning. So the beginning where it says, if next month is August, that is your given. Then this month is July, or that we are in July. That is the statement you're trying to prove. So you're already given the first and third bullet here. You have to come up with a chain of evidence. That's why we had to come up with the Gregorian calendar and the Bill of Rights. The last thing to note there is that this actually forms the acronym GES, or guess. So as ironic as it is, because we're not guessing at all, that's the method we're working on. So if you can remember the irony in saying that we are guessing, that is how the structure of the proof. The given, the evidence, the statement. Let's take a look at those specific facts or definitions. In this case, they're called properties in math, that we use to solve equations specifically. So we're going to make a few notes over here in the highlights and then highlight a few things over here. So if you want to underline them, you can, or you can just listen in. So the addition, subtraction, multiplication, and division property are all things you've learned before, and they deal with this thing called the inverse. Again, you don't have to write that down if you don't want to, that piece at least. But that inverse idea is if you're solving an equation that looks like 2x equals 10, I'm doing the opposite operation of multiplication, so I'm going to divide. Therefore, x is equal to 5. A one-step equation that you've learned in various stages of middle school. The reflexive and symmetric property are just as they sound. A equals A, or you can rewrite A equals B to be B equals A. The two I want you to star are transitive and substitution. The transitive property, we're going to make some connections here. The transitive property is the same thing as that word syllogism. So that idea of connecting two conditional statements together to form one final statement. We looked at many examples in class as well as in the previous video. Those are connected. Transitive and syllogism are the same thing. And then finally, substitution. Substitution is equal to the word simplify. And I really want to harp on that because simplify is a word we're used to seeing that's doing PEMDAS or that's just simply doing an operation. When we use the word substitution in a proof, we really mean please simplify the previous step. That's what is really being said. And finally, the distributive property is something we are definitely familiar with from various stages, again, of middle school. So if you flip your paper over after you've got everything written down on this sheet, flip it over, you can then see what problem or example problem looks like. So you can see I've already highlighted this, but this again will get to the given in a moment, so you don't need to highlight that just yet. So our goal is to prove that the equation 2 times the sum of x and 7 equals 6. Then x is equal to -4. And what I want you to do is add these quotes in here, here, and here. And in both of those, with those quotes there, we can see this is a conditional statement, something that we can given a true or false value. But we can't just guess here. We have to give the evidence as to why it is true or that it is false. And you can already see based on the actual example that this is indeed true. But let's look as to why. So wait to write down these yellow boxes to the end while we go over what's happening, because you're going to highlight some things. So first is, the first step is always to restate that given piece. Restate the given is always a guarantee to get at least one step of your proof. And we're rewriting what equation we're solving for. Then we're going to think to ourselves, we could either distribute, that's one idea, which we'll talk about in future classes, or we can divide by 2 at the beginning, which is what this person did in this example. So when we divide by 2 in both steps, we need to state that that's because of the division property. After we physically have it written down, we need to then do the division, which is exactly what step 3 is, or we told you this really means, if you could add this, this is to simplify. Sorry, I'd warned about my writing and I'm not living up to it. It's to simplify. So again, you're going to divide by 2, which in this case, these are going to cancel. And then you're left with x plus 7 equals 6 divided by 2, which is 3. So that's where that connection comes in. We're physically doing what we said what the property was in the last step. Then from there, we have one step left, which is to do subtraction. But instead of showing the work, we're going to use the expression here to show that we subtracted. So we're going to then say to ourselves, okay, subtract 7 on both sides. 3 minus 7 is -4. 7 minus 7 is why that goes to 0, leaving our x to be by itself. And that was because, again, of the subtraction property. So if we're looking, we have 4 pieces of evidence, and we have 4 statements that we wrote out. One was given, and 1 was the conclusion that we're trying to prove. So let's look at those things I'm going to try to circle them as I'm saying them so you can follow along. So always state the given first is extremely important. So we're going to take a minute to jot that down. Again, if you want to listen and then write them at the end, that's fine. It's up to you. The second one is then to state the step you just completed, not the step you plan to complete. So if you're looking at the subtraction property, we just did that from the previous step to that one. So we don't need to actually bring that up in the previous step. We're saying that as the final piece of evidence. So here's an example of that. So again, I'll circle the one we just talked about. And finally, your final step must, keyword has to have or include evidence. You have to have a statement to conclude. If you have all this evidence and not one for the final step, you're missing the boat. You're missing the idea of the proof in general. So this is the idea of the flow proof. And the next part, the very bottom, is for you to fill in, but we're only using the info from this example to fill in that information. So let's take a look at that final slide before we wrap up this video. So if I get back to my red marker, there we go. An alternative to the flow proof, you can organize your chain of evidence vertically, right, up and down, separated into 2 columns. Those 2 columns are, as you can see, written here and here. Those are statements, and reasons. And that's, it's another way of saying evidence and statements. It depends how you want to look at it, because statements we need to keep the same, but reasons, evidence, they're synonyms. They mean the same thing. So you're going to go back to the previous example, and you're going to grab those pieces of information. So if I'm looking here, I'm going to take all of my statements, 1, 2, 3, 4, and I'm going to place them vertically in this space. So I'm going to start with my given and go all the way down to my conclusion. Then we're going to go back, look at what evidence is provided. I'll use a different color to highlight. I'll use pink. This is the evidence as to why I was able to do that in each of my statements. And that's what you're going to write here vertically in the reasons column, or again, in our evidence column. The next time we join in class, we're going to take a look at how to compare a flow chart or a flow proof to a column proof, and what's the difference between the two, and it's really just in their appearance. And we'll talk a little bit about our future proofs, being in geometry, what structure we're going to use for those. So again, if you need to look at anything else in the video, I would definitely make sure you fill in the words back in the constructing proof, go over those examples of Gregorian calendar as well as Bill of Rights, and then finally take a look at the highlights from those properties of real numbers. You will be using those quite frequently, so it's probably good to get acquainted with each of those 9 properties of real numbers. So thanks everybody for your attention. I apologize we got up to 13 minutes. I thought it was going to be shorter. Again, if you need to watch it again to review it, highlight the different pieces you need, and we'll review the rest in class. Thanks so much. Talk to you soon.